about angles today, and that's why we bring up pool room and pool room math. You know, if you think about playing pool, if this is like the side bumper, what you can do is you can take the ball, and when you hit the ball towards the bumper, it's going to travel here, it's going to hit the bumper, and then it's going to bounce back, and it's going to form an angle that you come in on and an angle that you come out off the bumper on. So today's lesson is all about angles. So that's what we're going to talk about today. So first of all, what is an angle? Well, an angle is two rays that share a common endpoint. So you see I have ray AT, I have ray AP. Ray AT and ray AP make this angle. The rays are the sides of the angle. The important term, though, is the vertex. The vertex is that common endpoint. And the vertex is one way that we can name an angle. So I would write this as angle A. And please notice my angle symbol that I like to use. I like to use like a less than symbol with a little arc that goes through it. That's kind of the way that I do less than. Or that's the way I do angle measure. So I can name this as angle A. I can also name it as angle TAP. I can also name it as angle PT. Whoops, not PTA, I'm sorry. That's the wrong one. PAT. Let me explain why that's the wrong one. If you notice, the vertex is in the middle of each one. And that's key. The vertex has to be the middle letter if you use 3. What would be wrong is if you said like angle PTA. This would mean the vertex is at T. So that's no good. Don't do that one. Sometimes we can only use one letter. Sometimes we need to use 3. So what I'd like you to do is take a look at some of these here. And let's name all the angles in the figure to the right. Why don't you give it a shot, and I'll wait here for a sec. Okay, if I look at the one here, this diagram with the T, U, and V, I definitely have this angle down here at T. I can also call that angle UTV. Because the only angle whose vertex is T is this angle right here, I can use one letter. Likewise, I could say that another angle is angle V, this angle over here. Or if I want, maybe I can name it as angle TVU. But once I get up towards angles whose vertex is at U, I have to only use 3 letters. Because if I say angle U, are you looking at this angle? Are you looking at this angle? Or are you looking at the whole angle? So you got to be specific. For example, if I want this angle that I'll write in green, this angle here, that's going to be angle TUV. If I talk about this angle that I do in black, I can call that angle RUV. Or, do you see that that looks like a number 1 in the middle? You can always number an angle as well. Sometimes that's helpful. Oh, and did you see one more angle here? I'm going to do that in bright yellow. Look at this angle. It's those two combined together. Angle TUR. So a lot of different ways to name those angles. If you take a look at the one on the right here, I have angle XAY. That's this side of it. And you'll notice I'm drawing like little arcs for the interior of the angle. You can also have angle ZAY, or the entire angle, angle XAZ. Notice the vertex on each of those is at A. Just like segments, 2 angles are congruent if their measures are the same. And take a look at how I've marked them. I put that little arc through it over here, but I then put a little tick mark through it as well. So that helps me show that these 2 angles are congruent. So again, I would write either angle DOG, angle dog, is congruent to angle cat. If I want to specifically talk about their measures, though, I would use this M notation here and say the measure of angle dog equals the measure of angle cat. Remember, like segments, if we want to talk congruencies, we don't need the M's. If we want to talk about specific measures, we need those M's. And what's behind this one? Oh, an important one, an angle bisector. Think about this word bisector. The prefix bi means 2. The root sect means cut. So it cuts something in 2. An angle bisector takes one angle and makes 2 congruent angles. So we would say that ray CD bisects angle ACB. And as a result of that, we can say that angle ACD is congruent to angle BCD. That's what an angle bisector does. It takes one angle and makes two congruent angles. It's kind of like a midpoint. A midpoint took one segment and divided it into two congruent segments. So midpoints and angle bisectors do similar things. All right, let's play for a little bit. We want to name some congruent angles. I'll do that one first, and then we'll name some bisectors. Take a minute, see how you do. I'll wait here for you. Okay, how about we say that angle SRP is congruent to angle QRP. They both measure 52 degrees, so they're congruent. And that means that RP bisects angle SRQ. Oh, and this one here on the right is a lot of fun. How many congruent angles do you see? I actually see 4. I see the ones that are marked. Angle YMN is congruent to angle EMO. Those two angles are congruent. Watch this. Do you see this angle here in the middle, angle NMO? If I take its measure and combine it with the angle on the left and combine it with the angle on the right, I get two other congruent measures. I'm adding this blue angle to the other pair of angles. So I'm going to say that angle YMO is congruent to angle EMN. So that's some stuff on angle measures.